Hey guys, welcome back to the shop. My name's Adam. Alright, so I'm getting ready to start on my next job here. I want to share it with you and explain to you what I'm doing here. So we've got a set of exhaust manifolds, and these belong to the same customer that had brought me those little short cast iron exhaust manifolds that I had shortened in a past series of videos. Can you shorten my pipes? These belong to him also, and actually those pipes mount to these manifolds here. But all right, so what we got, this one here he brought as a sample because I was able to get my measurements off of it. This is the one I've got to do some work to right here, and just making sure you can see. What he wants me to do is drill the hole in there for the butterfly that's going to be inside. This one's still in there, and it's all hooked up and working. And what it was on this one, this was another one that he's had, and he wants to fix this one so that it's in good shape and it works. So what had happened was the holes, the pin that goes through there, it's a 5/16 pin. Somebody in the past had actually tried to drill them out, and they got the holes egg-shaped, and so you couldn't use it. So he had a welding shop welded up both sides, and they got it welded all the way through. They went inside the hole here and ground it smooth. So I've got to set this thing up and put that hole through there, and this is going to be a 7/16 hole. He actually had another one with him whenever he brought these that had the bushings in there for me to measure. So the bushings that go in here are the OD is 7/16, and then the ID is going to be a 5/16. So the other thing that I decided, I don't know how hard this is going to be. I'll give you a little closer shot there of the welding. They did a pretty good job. You see on the back side there. I'm not sure, it may be a nickel. They might have used some kind of nickel rod, I don't know. So that may be tough and hard to drill through. And the other thing is that it's off center. It's not directly in the middle of this, it's sort of off center. So once you get through the top, then you got to worry about keeping it straight going through the bottom there. So what I wanted to do was go ahead and buy me another tool to do this with, and that's what I did. I bought me a 7/16 carbide straight flute drill bit, and that's it there. I just got this, and I get a pretty good deal on cutters from work, so it didn't cost a whole lot for that, but I wanted to have it for the job, and I'm planning on using this to drill the hole through there. And I'm hoping that using this type of drill bit will allow me to easily go through that weld in the cast, and in case it's hard, and get through that. And as it's coming through and it starts in that other side right there, maintain a straight alignment and go on through to the back. So that's what we're going to use to drill the hole. And I've used these over the period of years. I've got a few small ones, and they're excellent drill bits for tough jobs, hard materials, things like that. I bought a small one a while back to drill some little holes in some bearing races, and so they'll cut. They do a good job. And after I get the hole drilled, I've got to make some stainless steel bushings to go in there. And I don't know what I'm going to use, but he brought me this bolt. This is a stainless steel bolt, and he said, here, use this, you can make your bushings. So I might just use that since he brought it. Just cut the head off there, chuck it up, drill it, turn it, and part them off. And they're not very wide. I think they're only like 3/8, and then knock them down in there. So that's what I got to do. It's a little bit of a tricky job, and I've spent probably a good half hour trying to get my measurements off of this one so that I can precisely put the hole in this one where it needs to be. Okay, I had an interruption there. So what was I saying? Oh, the alignment of the hole. Okay, it's when this thing is pulled down flat, if it's pulled down flat on the table, this is 90 degrees here, this flange, but that hole is not in line with this face right here. It's actually kicked up. The part will be kicked up at an angle, and it's somewhere between 5 and 10 degrees. So what I've decided to do was use my adjustable angle plate like I showed in the piston video. I'm going to use that, and I'm going to get it indicated, get this indicated straight across. You know, we're going to get it straight and square, because what I need to do is work off of this pin. This right here is what I'm getting my measurements off of. It's just like the one on here, and I spent a lot of time using some old school measuring instruments here, you know, my scale, my calipers, and some other stuff, and I finally got it figured out where it needs to be. We're going to be moving from this center line of this pin here, we're going to be moving down 15/16, and we're going to move over 3/16. So what I want to do is get this pin indicated straight up and down, and you know, get it square, and then we'll center up on it and move down. That would be the location of the hole. So that's what the plan is, and feel pretty confident. I've got it figured out now. It's if it's off just a little bit, it's not going to kill the job. It can be to the side just a little bit, because the butterfly that's inside there is not, I mean, you've got gaps all the way around it, so you've got a little bit of room to play there. But I've been taking the measurements, and I feel like I'm good to go. So, all right, I'm gonna go ahead and start getting it bolted over there and getting it indicated and getting it set up. Okay, got the manifold bolted down, and I got it kind of roughed in on flatness here, and I'm going to get this flange indicated. I'm going to use the Noga and my Starrett dial, and I had to raise it up. I've got my big parallel sitting here on the V-ways, and so I could get enough height. So I'm just going to run it back and forth. We're just going to use about 5/1000ths of it. That's why I like that fine adjust bottom. Dial it in. Well, how lucky can I get? I mean, I just eyeballed it from tip to tip there. I mean, it's pretty much there. It's you got a little bit of corrosion up in there, so it's a little low there. You know, I really hate to bump it around, because that's pretty close. So let me snug these up and just see if it's going to stay there. That's not bad. I mean, I think that's, for what we're doing here, I think that's plenty close. I'm going to go ahead and make sure these are torqued good. I'm just using some bolts and some small T-nuts here on the angle plate. Alright, I think we're going to live with that. Alright, the next thing I want to do is try to get all this area here level. And I was going to try to just indicate this rod, but I feel pretty confident after, you know, playing with this surface here. I believe that these holes, this pin here, this surface here was all in line, square with each other. Now, I don't know that to be fact, but that's what I think it is, and that's what I'm going to work off of. You know, this doesn't have to be dead nuts accurate. As long as we're close, it'll work. So I've got it kind of leveled up close, and if we put the level here, you can see that the bubble's off a little bit there, and I'll put this up against the pin and pull it up square with the pin. The bubble's off the same direction. I'll put it on that side, it's the same way. I did kind of rub it with a file. I just kind of dressed it like that. I took some emery and cleaned the pin off. So we're just going to use a level to get this one squared away. So we gotta kick it down a little bit. And that brought us pretty close right there. That's between the lines. That's between the lines. That one's between the lines. My eyes are playing tricks on me because of all these different angles going on, and it looks like that pin ain't straight up and down, but I know that it is because the level's telling me. So it looks good. I'm going to go ahead and tighten up the angle plate where I've got it set, and I'm going to call that level. Snug up that side, and well, I can't reach this side because I got the camera sitting in the way, but let me get that snugged up here in a second, and we'll move on. All right, I'm going to start getting this pin located, and I don't have enough room to use my coax indicator. I was hoping I could put that in there and indicate it that way, but what I'm going to do is probably just use my collet here, 1/4 inch collet, and see if I can't get it lined up really close, and then I might put this Brown and Sharp indicator in there and see if I can indicate it a little bit closer. We'll just see how it goes here. So let me get it over there close to it. All right, there it is. Bring the table up a little. All right, that's pretty close. I don't think the pin is perfectly straight in line with the collet, so I might go ahead and put that best test in there and see if I can find the center of it that way. Yeah, I keep moving it too far. This thing is pretty touchy. All right, we're pretty close side to side. Let's go front to back. I think we're close enough to make it work though. Okay. Now it's wiggling around the 14 to 16 mark. So I think I'm going to call that in line with the pin. Now if I move that up or down, it'll probably change a little bit, but I was trying to get down close toward the bottom. But that's about, I ain't got much further that I can move it, so I'm just going to leave it at that. And I'm going to go ahead and lock the table because I need to set my dials. Okay, that's good. All right. All right, I got you in front of it because I wanted to give you a point of reference of what we're doing. I've got my little sketch here, so this will give you the idea of what I'm doing. This black dot is the pin, and the circle here is the hole that I'm going to put in. So we're going to move the table that direction. We're going to move over 187 thousandths or 3/16, and then we'll move the table back, and it'll be 15/16 or 0.937. You know what? I forgot to turn on my my double boost light here, so let's see if that helps any. Yeah. Sorry about that, John. Okay. Got the table locked. I've got my dials on 0. I don't have a fancy digital readout to use here. Not now anyway, but I will. All right. We're going to move 187. All right. Lock it. Unlock the Y. We're going to go 937. Alright, it's 8, 9, 35, 6, 7. Alright, well that's where the hole's going to be. Hope it's right. Alright, I was trying to find a good camera angle for you, and I'm having a difficult time because I wanted to get you in there close and see the cutter. And I might move it in before I start, but I'm just going to show you how I'm going to do this. I'm going to use the Keith Fenner technique that he showed on using the handle on the mill, like for the power feed, except manually. So you turn it on and you engage it with it in neutral, and you rotate your handle, and you can move the spindle up and down. So that's how I'm going to drill the hole. Instead of holding the quill handle and pulling it down and risk busting that drill, I'm just going to slowly feed it like that. And I'm also going to keep the spray mister on there. I want to try to keep it cool, and also to help blow the chips out of there, keep them from binding up. So that's what we're going to do. I'm going to try to get you in a little bit closer so you can see what I'm doing. I just wanted you to see this technique with the, you know, with the handle here on the quill. All right, here we go. Let's at least start the first hole and see how it does. It's going to be a little noisy because of this air. I'm going to run 1750 RPM. Back it up and see how it's doing. Okay. Looking pretty good. I can feel some valleys and holes in there. I'm just trying to move the handle here nice and steady. get my flashlight. That's to be expected. There's some valleys and dips down in there. Alright, starting to come through now. I'm going to put a little bit of tension on the quill there. Okay. Let's see how it did. Alright, the drill looks good. And I got my first hole. Okay. Now what I'm going to have to do is I'm going to have to move that drill down in that collet. And the other thing that's going to give me a problem that I didn't think of was that pin sticking up. It's going to interfere with the spindle too. So I'm still not sure if that drill is going to go all the way through this thing, but I'm going to try. Let's see. The stupid pin is right. I mean, it's just touching that damn thing. It's really messing me up. That was the only length that I could get though. I don't know if this thing's gonna be long enough. Nope. It ain't near not long enough because of that pin. Dang it. Alright, I gotta do some thinking. Figure out what I'm gonna do next here. Alright guys. Well, I did the first hole and ran into a problem, and as soon as I did, I had interruptions come up on me, so I just stopped what I was doing, and it's a new day and I'm out here again, and we're gonna try to get this thing finished up. So what I didn't really think about was gonna mess with me was the pin that's sticking up here. That little bit of length right here is messing me up where I can't get the drill down through there. Here's my carbide drill that I bought, and I even tried just catching just a little bit of the collet, and it just wouldn't come down there even enough to start a hole. So this isn't going to work for the bottom hole like it is. I need it longer, and I don't have one that's longer in carbide, so I'm going to attempt it with the high-speed drill and see if I can get the hole drilled. So I'm just going to take it easy, run it slower, and see if we can get it started straight. That's my main concern. I mean, I'm sure I can get the hole through there. I just want it to stay straight. So we're going to give it a shot. I moved the little double boost light down so I could see, and I'll probably just use cutting oil instead of that spray mister. I'm going to get it down here close, and then I'm going to get the auto or the feed engaged. Yeah, it's tough, I can tell already. You don't normally want your cutting tools to just dwell, but I'm taking it very slow, just hoping that that drill is just chiseling away at a center point there to keep it straight. But I can always regrind it if it messes it up. No biggie. Seems to be doing pretty good now. Hitting some little fissures and little valleys in the welds. Back up a little and see what's going on here. All right, I think I got a dull edge already, so let me check everything out here and see what's going on. All right, I had to regrind the drill bit. It was already dull. Give it another shot here and see what I can do. I'm doing it by hand now because I need to feel what's going on here. There's a hard spot in there it keeps hitting. I'm going to use the feed handle here. I feel it coming on through. All right, there it is. Ooh. Okay, and we made it. All right, well, we got a hole through there, and so let me get everything out, and we'll move on to the next phase.